get 1,000 miles from the Earth, a rocket would need this much power, 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 this much power.
Shemai, welcome. Today we're going to be making a lightning powered candy dispenser sweep machine, like the ones you've probably seen on Twitter or on YouTube. They're very good fun. It's quite an intense tutorial, there's quite a lot to get through. Obviously we're going to have to build the hardware and then we're going to have to write the code for it, so it's going to be a longer one. It will be very beneficial if you haven't seen the previous tutorial on, say, the Bitcoin price checker, which is a fun little tutorial and it's using very similar hardware. If you could go and check that one out first, that'd be great. If you've already seen that one, then great. This is kind of a follow-up tutorial. We're using pretty much the same, some of the same code to run this project. We're just building a little bit of hardware to go alongside it. We're going to be using OpenNode, the custodian, because they're brilliant and the service they offer is really good. We can, in the future, look at porting it across then to our own Lightning node if we want to. I'm currently setting up the Raspberry Blitz, the new version of Raspberry Blitz. Raspberry Blitz version 1 came out. Christian released that a couple of days ago, so that's downstairs cooking away as we speak. And as soon as it's up and running, I will be putting in some patches into the GitHub. And maybe I'll do a little follow-up tutorial as well on how to support some of these projects across so they run in financial self-sovereign way, which we all like, of course. But OpenNode, very good, well worth checking out. Go make an account, play around with their software, it's great. And it's going to be really useful for us because all we need is the candy dispenser and then the ESP32 and a cheap ePaper module, and an account with something like or you could use something like Strike if you wanted to, which is another Lightning custodian service, and we can get up and running accepting Lightning payments on our sweep machine for sweets. So without further ado, we'll get into actually building it, I suppose. We'll be using this candy dispenser, which is relatively easy to pick up from Amazon and cheap. The ESP32, which is used in the other tutorials, an ePaper module. You can use this one or the WaveShare one, this one's cheaper. Some jumper wires, a LIPO battery, an NPN transistor. So the transistor is going to be connected to a GPIO on ESP32. Once the Lightning invoice has been paid, that's going to send an on to the transistor. By sending it on to the transistor, it will then allow the 3 volts to come out of the ESP32, and then that'll turn the motor on. We don't have enough power coming from just the GPIO to turn the motor on, so we need a little transistor, a little electronic switch to do that for us. We'll also be using a little switch. This little switch is going to be used for power saving. So when the sweep machine is not in use, it's going to go to sleep, which as I said in my other videos, radically decreases the power consumption. And then when someone wants to pay for sweets, they can press the little button, it'll wake the device up and then display the QR code. We're not going to be using many tools. We're going to be using a screwdriver, a Stanley knife and a drill. I've got a little Dremel drill here, these things are really useful if you're into packing and building stuff, but a regular normal drill will be absolutely fine. We'll also be using a solder iron and some solder as well. So not too many tools, all things which you haven't got you should get. So yeah, let's crack on taking this thing apart and seeing what's inside. Just going to take the candy dispenser out. I thought it kind of made sense to show what you get sort of from scratch and then work our way out. So this is the candy dispenser. Obviously we're going to fully mod it, so we're going to sort of take it apart. The way the actual candy dispenser works, just as it is out of the box, there's a little touch sensor there. When you press the touch sensor, then it turns the motor on, which then spits out the sweets. But obviously we're not going to be using that, so we can take that off. Okay, so this just unscrews off there. This part here we should just pull out. Okay, and then we'll find in here there's a little like Archimedes screw, I think that's what it's called, and that. There's a little motor in there. When the motor turns, that then turns, and then that kind of spits the sweets out the front here. So we're just going to put these all to one side, I guess. We're going to use our screwdriver here to unscrew these little screws in here. There's only 3 screws. Now, what have we got in here? So, yeah, we can safely just rip this off here. So there's a couple of wires coming from the base of the sweep machine where the batteries are stored to power the motor. We don't need those. This is the little circuit board which senses someone touching the sweep machine and then turns the motor on for an amount of time. We also don't need that, so we can rip that out of there. We don't need these wires here, so we can rip those off there. And if you want, you could take this out. I mean, I didn't really bother, but let's rip those wires off so they're not kind of in the way. Here's our little motor here. Okay, and it's got a little resistor between it there, which I also don't think we need, but I'll leave on there for now. Okay, so let's see if we can get into our base. Right, so we have a couple of little screws here, so we'll take those off. There we are. Okay, we have in here, we'll take these little things off here. We'll just smash through them. Yeah, I'm just going to smash through them. Right, so 4 screws. Now, when you take the base off here, you'll see there's a little switch, which we don't need, so we'll take that out. Well, we could probably incorporate it into our design if we wanted to, but I can't really bother, so we'll just take that out. We're not going to use this base at all, so we're just going to fully discard it. I mean, yeah, we're not going to use it. We're not going to use it. We'll make our own base. So there we are. So we have a nice cavity here, which we can stick our ESP32 in, and then yeah, the motor's there. There's the motor there. Yeah, there we are. We don't need that wire there, so we'll pull that out too. Okay, cool. So the first thing we're going to want to do is make a nice big holes for our wires to come through on here. So I'm actually going to screw this back on there to keep it in place while I drill. Yeah, see, so we want to be able to thread our wires through there, and the little hole which is already there is a little bit too small and annoying, so we're gonna sort that out first thing. So I'm just going to screw right between those 2 screws. You can see there now I've made a slightly larger hole to stick our wires through. Okay. Now I'm going to take this top bit off again. Okay, now, so we're going to want to put our ePaper module in the base here. Now, if we put it too far back, then we're going to struggle with our camera, because remember the little lip thing comes out here. We're going to struggle with our phone to actually take a picture of the QR code, or to scan the QR code. So I'm going to put the ePaper module about here. We need enough room to be able to, we're not going to use the little back socket thing, because when you order these, I ordered a whole bunch and they didn't come with the wire which plugs into here, the jumper thing. So you just solder on the pins on here, and it's got the same connections, the SPI connections. So flip that round, and we want that to be about there, don't we? Oops, if I draw around it. Now, the only issue is obviously we've got quite a lot of big bulky transistors and capacitors and this module-y thing. So we're going to have to kind of cut out a cavity for that to sit in. But obviously we want to kind of keep these screw holes here because we're going to need to utilize those. So we've got something to screw into. So if I do a dot there and a dot there, you can kind of see that. So I want to keep that bit there. But I will need to kind of cut this bit right up to the edge in order for this to sit in. So that's kind of what I'm cutting out, if that makes sense. Yeah. And then hopefully then that should just kind of slot in there quite nicely with these pins sticking out the other side so we can actually plug something into them. We need to, I think we might get away with not cutting right to the edge, we'll see. Now, you could do this, you could cut this with a drill. You could just drill holes, little tiny holes, and then, I don't know, maybe use your Stanley knife or something to clean it up if you wanted to. Or if you've got one of these Dremel type things, you can use one of the cutters, which I'll probably use. But I'll show you the drill just to kind of give you an example of how that might work. So I mean, it's relatively easy to cut into, but we don't want to make a mess of our sweep machine and make it look ugly. So you could go along and you could kind of drill out the shape there, but I'm going to use my little cutter. I've made something of an abysmal mess on these bits here, so I'll have to have a little look later on, see if there's something I can do to tidy up. The top bit looks pretty cool. Obviously you can take your time more than me, and then you can make sure that the rest of it kind of looks the top bit, but I've really savaged those bits there. Hopefully maybe when it's on the table you won't be able to kind of see. Oh, no, you can see it. I'll see if I can put something in there to make it look a bit neater. We're then obviously going to have to drill a couple of holes so we can screw this in place. So we'll do a hole there, and a hole there too. Now, word of warning, this material, because it's kind of like a black plastic which is being sprayed silver, it's really easy to kind of scratch and scuff and make it look crap, so just take your time in what you do. There we go, I've got a couple of holes there to screw our ePaper in, or ePaper module in. That's pretty sweet. Now, the ePaper module itself comes with these 4 little plastic nylon screw things. So we're going to use 2 of those, and we're going to put a screw in here. There we go. And then a little screw in there. There we go. And also, actually, the ePaper modules themselves are also incredibly easy to damage. Thankfully, these ones come with a little plastic cover which sits like that on top of it. So actually, in fact, we should put that on as well. But that just means that you're not going to, because if you hit that ePaper there, it's very easy to kind of crack the ePaper. Right, these screws are just a little bit too small to go through the material, so I think I'm going to have to put a little bevel in very carefully. Now we're going to use, just to make it kind of look a bit neater, because I've had to really force those screws in, it means that the plastic is kind of raised there, so we're going to screw those down to make it look a little bit neater. So we're going to use our other 2 little screws. Yeah, it looks pretty dope, apart from the bit which I butchered, obviously, but there we are. Our ESP32 is, it's going to kind of get screwed into the back end of that screw hole there. Let's keep it in place there, which is pretty sweet, good, nice and tidy. However, because the legs are pointing downwards, we need to kind of bend a few legs out, which we're going to be using. So we're going to be using the, if you do this quite carefully, it's probably advisable. We're going to be using the EN leg, which is going to be used to reset the ESP32. We're going to be using the, obviously my Stanley knife is quite blunt, so I can do this. I wouldn't do this with a sharp Stanley knife, it'd be pretty dangerous. We're going to be using pin 27 there. So maybe get up a fork or a knife or something. There we go. Let's do it. And then on the reverse, we're going to be using the ground and the 3 volt, like so. We're going to be using the pin 4. So now these are the same SPI pins which we used in the last tutorial. Pin, what have we got here? Pin 5. I can't stress enough how blunt this Stanley knife is. Don't do it with a regular Stanley knife, you'll end up cutting your fingers open. D21, which is that one there. There we go. And D22 and D23. Come here. There we go. So there are all the pins which we're going to be using. Oh, and the 5 volt in for our LIPO battery, and the ground wire for our LIPO battery too. So these two on the end. There's a schematic on the GitHub, so that'll make this a little bit easier, won't it? And then with those legs all bent outwards, that will then screw in there like that. So I wonder if we can just use one of these screws here. I bet we can. Yeah, baby, I think we can. If not, we'll have to find a little screw to screw in with. Right, just to skip us along a little bit, I used a soldering iron to make a little hole for our switch, and then popped our little push switch in there. That's going to be there to reset the ESP32. So I screwed the top of the sweep machine back on, so I could start threading wires through and so on. Next I moved the capacitor between the 2 diodes of the motor. It's a little bit fiddly to get off, but I just managed to pull it off in the end. I soldered 2 jumper wires onto the motor, so we've got something to plug into. Always remember when soldering to heat the element and then push the solder into the element. I threaded a wire through from the top of the sweep machine to the bottom of the sweep machine, and then plugged that into the ground GPIO pin next to the 3 volt pin. That's a female to male jumper wire. Before we move on to the next stage, it's quite important that we just cover transistors quickly. The little NPN transistor we're using is just an electronic switch. So there's 3 legs to the transistor. There's the emitter, and then there's the collector, and we've got a middle leg which is our base. Okay, so a charge collects on the collector, and then it's not released until we add a charge to the base, and then it's released and it can go through the emitter. So this is just a way of us being able to activate a switch so we can get the charge to our motor. I added another wire to the ESP32. I did a white wire to the 3-volt GPIO pin, so that sort of sticks out the top there. Now I'm able to get our motor and plug our motor into the ground wire. With the motor, it's sort of bidirectional, so it doesn't really matter which one of these jumpers you plug into. I mean, it will, because it'll determine whether the motor spins one way or the other, so the switch will either go up into the machine or come out of the machine, but for now we don't really know, so we'll just plug it into one of them, we'll be fine. So now we have these 2 loose female jumper wires here. So I'm going to get my transistor, and then plug the positive wire into the collector, and then the other the wire from the motor into the emitter. Now you'll see that the base of the transistor hasn't got anything plugged into it yet. We're going to plug that into a regular normal GPIO, which we can turn on, and we can send a small charge to, which will then allow current to flow from the collector to the emitter. So for that I use a regular normal male-to-male jumper, and we thread that through, plug it into the base, and I'm going to choose, I mean the pin we choose is fairly random, but we bent out the pin 27, so we're going to use pin 27. And just plug that jumper into pin 27. Stuff the wires into the cavity of the sweep machine, the transistor, and then squeeze that top bit with the motor on top, so the little nozzle pokes through the little hole, and then screwed it back into the base to keep it nice and secure. I got the just so I don't lose it, I got the little Archimedes screw and popped that back into the sweep machine itself. And then I also got, there's a piece which then sort of clicks on top of that, just to ensure that the sweeps don't get all tangled up in the motor. So I clicked that back into place, which meant, like, you know, hopefully kind of done with the top bit now. We won't have to fiddle around with that too much anymore. These ePaper displays, which I ordered, didn't come with the wires, so I had to solder in the pins for them. We're going to skip the first 2 pins here. I'm not going to plug them in, the 3-volt on the ground, because we're going to have to tap into these 2 wires a little bit later on, so it's going to be a bit fiddly, going to have to do some soldering. So first we're going to plug into the SDI wire. And that goes into pin 23. This is the exact same layout as the price checker video tutorial I did, which if you haven't seen, you should really watch. Next is the SCLK, the clock pin that plugs into pin 18 on the ESP32. CS, which is chip select, that's used to say if you had like multiple modules plugging into an ESP32, you could select those. They could all use SPI, but you could select different modules using chip select. So that plugs into pin 5. DC, which is data connect. DC is going to plug into pin 22. RST, which is the reset pin. I'm not entirely sure you have to necessarily plug this one in, but we'll plug it anyway. That plugs into pin 21. Oh, got the wrong wire there. Got a female to male. There we go. Go for a yellow. Yeah, so RST goes into the reset pin, goes into pin 21 on the ESP32. And the final pin, which is busy, that's going to get plugged into GPIO pin 4. And there we go. We can sort of fiddle these wires. Some of these wires are already falling out. These are older jumper cables. I'm starting to run out. I need to order a new batch. They loosen up after a while. So it's just a case of kind of stuffing all those wires in and trying to make them look neat, really. Which we can do. We bend them around the switch over here. You could use a little bit of tape or some blue tack or some maybe a glue from a glue gun or something could neaten it up a little. You'll have to accept my apology here. I did actually record soldering some of these extra wires, but I then deleted the recording, which was clever. So all I've done is I've connected the ePaper power GPIOs to the power, the 3 volt and the ground on the ESP32. Now the way I've done it is I've bridged from the 3 volt pin on the ePaper across, and then I've sort of tapped into the 3 volt wire coming from the ESP32 here. So I've just taken off a bit of the plastic on the wire. I actually used a soldering iron just to melt it off, which is very cowboy, but it works, who cares. And then I soldered a bit of wire in place, and then I did the same, making sure to do a decent distance away from there so we don't end up shorting. On the negative, I had the negative wire come out, and then I sort of like tapped into this negative wire which runs down to the motor. So I burnt away the plastic and then soldered him on. I also connected the reset button. So on our ESP32 we have an EN pin. The EN pin here is the same as the EN button here. Once that's grounded on the ESP32, it will reset the whole ESP32. So all we need to do is connect a jumper cable from there, from the EN pin, to one of these diodes coming off this switch, and then the other part of the switch here, the other diode, then connects to that ground junction over here, so the same place where I connected the ground from here. Yeah, it's absolutely fine. It's all just going into the ground, which is just there, so it's absolutely fine. So yeah, I apologise for not recording me actually soldering that bit up there, but it was a bit long-winded, so this is probably a better way of doing it anyway. Okay, our hardware is ready. We've built all the hardware, so now we just need to write some software to actually get it to do something. We're going to start at the GitHub for the OpenNode edition of 1.21. So if you Google Arc BTC, actually the link will be in the description of this video. Now go to the GitHub. In the GitHub, there's a link there. Click on the link. It will take you through to OpenNode, where you can sign up for an OpenNode account. OpenNode does have, I've already signed up, OpenNode does have 2FA, which gives it that extra layer of security. It uses the Google Authenticator for its 2FA, so I've just got to put that in. Oh, it's changed already. I'm always too slow for these things. Okay. This is why. I'm in. Brilliant, fantastic. There we are. Now, then when you go into your dashboard here, you'll have your balance and a bunch of tools and other things you can use. There's some pretty nice. If you go to tools here, there's a nice quick invoice tool here where you can just quickly generate like a lightning request here, which is pretty good. See if that's working. So we want it, do we want it on-chain or on Lightning? So let's go for Lightning. There we are. So that's quite neat, and that goes to your OpenNode account. And then the idea being, as I've said a few times, that once this all concatenates to a decent sum of money, you can then just output it to a mainnet wallet. So we're going to go to settings, and we're going to go to API keys, and we want to generate an API key, don't we? So I've got a bunch of keys which I've generated here before. You'll see that you have read-only API keys, and you have invoice API keys. We want an invoice API key because we want the sweep machine to be able to send a request for an invoice and then get the invoice. And we can also use that same API key then to check to see if the invoice has been paid. Okay, so we're going to click on add key here, and we'll call it sweeps. And we're going to go for invoices. There's also, as you can see, there's a withdrawals API key, but obviously that's you'll have to keep that one quite secure. Right, so this will generate an API key, so we're just going to make a note of that. I'm going to copy it. Let me stick that somewhere safe. Okay. Nice. There we are. Did that make the... Yeah, it did. There you are. So there's sweets down there. And I've got the API key. Now we need to open up Arduino. Once you've opened up Arduino, you're going to, because we're going to kind of have two files, just like with the price checker. We're going to have some functions to communicate with OpenNode. Just to make it a little bit neater and less of a mess, we're going to put those functions in a separate file, those OpenNode functions. Oh, look at all the jumper cables have come out. I'll fix that later. But yeah, you remember this project. If you haven't seen the video for this, then you should have. Please do go and watch it, because this is kind of the precursor to this tutorial. So if we go into the GitHub, if we click on main INO, then here is the Arduino code we need for our project. What I'll do is I'll just kind of like paste it in to the Arduino IDE, and then I'll kind of explain it. That kind of makes sense. Yeah, there we are. Paste that in there. I am new to all this stuff, so you know, if it's messy code or if it could be improved, please do leave comments in the GitHub. It'd be very much appreciated. Okay, so we're going to save as, and we're going to save it as, I've got a few examples of this. This is the sweep machine. Right, now we now need to, we've got our text editor open actually, so we could use this, couldn't we? We're going to make a separate file in our text editor, and we're going to, god damn it, just doxed myself. Separate file in our text editor. Okay, now we are going to make that separate file, so we need to, in order to get this to come up on the Arduino IDE, we make a separate file in our text editor here, and then here we go. If we go back and we go to OpenNode.h, in here then is the other functions which we're going to be using. We're not going to be using, so in the last tutorial, in the fetch payment tutorial, we made a function for checking the rates. We're not going to be using that because we don't really need to know the rates. We're just going to charge X amount of Satoshis for the sweets. Okay, so paste that in there, save, and we're going to save that. Where are you? Oh yeah, Arduino, the sweep machine. Okay, I'm going to save it in here. We're going to call it open. I do that every time I do that. OpenNode.h. Okay, cool. Close that. No, it hasn't popped up in the Arduino IDE, so if I quit it and start it again, it will come up. Come on. There we are. Okay, cool. There we are. So you can see here in this tab here, because those two files share the same folder, the Arduino IDE knows to open up that file when it opens up this file. And we include the OpenNode.h somewhere down here, I think. Where do we include the OpenNode.h? If you have a little look, we should be able to find it. Ah, there he is. So there's us including the OpenNode.h here. So if I just kind of explain the code as opposed to like write the code out, it's probably the easiest thing to do. I mean, a lot of this will look similar to the code we used for the price checker, because we're using the same secure library, and also the what was the other project? The panic alarm. We used the Wi-Fi client secure because we're doing HTTPS call. So these two libraries here are just basically to connect to the Wi-Fi, and the Wi-Fi client secure is to make a client which we can use HTTPS to do an API call to the OpenNode API. It returns, when we make that API call, it returns a JSON, so we need a library to be able to decipher that JSON, which is what Arduino JSON does. These two libraries here, these are for the ePaper display, GXEPD2, which is a really fantastic Arduino library. You'll need to download and install these before this file will work. So you'll need to include these either by going to the GitHub, or I think you can go install the libraries by going to include library, manage libraries. It might just be in there. If not, then download it from the GitHub and yeah. There's a QR code library which we're going to use, which is actually going to generate our QR code. There's a string library. I can't quite remember what that does. I think that allows us to take a string and then kind of like split it up, which I think we use a little bit later on. If we don't, then that probably doesn't need to be there. Yeah, I think we do use it. We've got a couple of fonts which we're adding, so we can actually put fonts on our ePaper. This here is telling the GXEPD2 what kind of display we've got. So we've got a 1.54 inch ePaper display, and it's then telling it what pins we're using for some of the SPI connections. Here we'll need to put in our Wi-Fi details. You'll need to put in your Wi-Fi details. This is the host, so we're connecting to the OpenNode API. We're using port 443, which is the sort of regular standard HTTPS port. This amount here, this is how much we want to charge for our suite. So 400 Satoshis is next to nothing, isn't it? So let's go 800 Satoshis, how about that? And this is where we put our API key. So we've already gone and got our API key when we made our account. So we're going to take our API key and we're going to paste that in there. And there's a description there, so we're just going to call it suite. So one of the reasons in which I like OpenNode a lot is because originally I was using Async Strike, but I really like the kind of back end to OpenNode, and I thought it was I just really like the sort of usability of it. Anyway, in order to make it quicker and easier for routes through the network to be found, in the invoice they included hints, and that made the invoice a little bit too big for my ePaper display. So I contacted them and I said, look, please, can you give me some sort of perimeter I can include, so to stop those hints from being incorporated into the invoice, which I suppose makes it a little bit harder for the payment to find a path through the network, but then I can actually fit the QR code onto the ePaper. And from my tests, I haven't had any problems like paying an invoice on it. So yeah, and like within like 24 hours, they'd added that perimeter to the API, which I thought was so cool. Yeah, so they really are. They're a great company. Destined for great things. Now we have a couple of strings here. These relate to when we actually make those API calls. This empty string will be filled with our invoice, our Lightning invoice, and then this string here, this will turn to paid. It will be checking our API, and then once our invoice has been paid, it'll go to paid. And then here is a data ID. So once we've generated an invoice, we can then use that data ID to then track that invoice and make sure to see to see whether it's been paid or not. We've got a couple of like random countery things here. There's a few of those sorts of things dotted about just to, for for loops and so on. A lot of this stuff here is so there's no, in this library, there's no easy way of generating the QR code or sort of displaying a bitmap on the actual ePaper, displaying an image. So we're having to kind of like generate that stuff inside the ESP32. So we get the invoice, and then we turn the invoice into, using our QR code library, we turn it into kind of a QR code made out of zeros and ones. And then we're going to pass through, that's what this little dictionary thing does here. We're going to pass through and compare those zeros and ones so we can actually build the hex values to actually build our bitmap. So yeah, the kind of bitmap, which is, I mean, I talked about this in one of the previous tutorials where we had an image, and you could see the kind of bitmap which it generates, which is kind of a big list of these hex values. So a lot of that stuff is for that. It was a real headache to try and make, and I've got a few people to thank for that, because they really helped out. George, the guy, came with the arcade machine, which you could pay for on Lightning. He really helped out on that one, so that was great. And then a couple of people during the hack days really helped me out there too. Okay, so we've got all our includes and we've declared all our strings, universal strings, and so on. So now we're going into the setup. So this is the kind of the first function which is going to run. It's just going to run through. First thing we do is we turn the display on. So we turn the ePaper display on. Next, we're going to flash the ePaper. So the ePaper display, as I said in the price checker tutorial, it's got the GXEPD2 library has kind of a funny way of displaying pages. So you have to kind of display first page, then display next page. This is just kind of a standard format for displaying data. And then this is where we've actually put in the data which we're going to display in the ePaper. So the first thing we do is we flash it white, so we clear any data which is already on there. And then we set the font, so a small font here, and set the text color. Then we position the cursor, so we want loading with a little smiley face to appear kind of halfway down the screen. So when you turn the Sweet Machine on, it says loading and gives you a little smiley face. It gives you a little bit of feedback and tells you to wait, be patient, it's loading. It doesn't take long. The next thing we're doing is we're running the serial, which means that we can, if we need to, we can test our code using the serial monitor when we compile it and run it on the ESP32. We begin our Wi-Fi connection using our Wi-Fi credentials, which we put up there. And then that gives you feedback saying it's connecting. Once it's connected, it's connected. We're saying pin 27. If you remember, that's the pin which we're sending an on to turn the transistor on to allow the 3 volts to get to our motor. We're just saying that pin 27 is going to be an output. So we're telling the ESP32 pin 27 is going to be used as an output. Right now, so we begin our main loop. So in our main loop here, we have our integer counter, which I think I declared up there. I don't know if I need to declare it there as well. Oh, and I think I'm probably clearing it because it's going to at some point loop round. Yeah, that makes sense. And then we're emptying this hex value array, which we fill up a little bit later on, I think. So now we're calling a function. We're calling the fetch payment function. So in the OpenNode file here, there we are. Can you see that? There's our fetch payment function. So it expects a string of a Satoshi amount. So our string of our Satoshi amount is 800. There we are. So where it says amount, 800 Satoshis. So where are we? Yeah, there we are. So we run that function. We put 800 in it. It then takes that 800 and it builds a post request to the OpenNode API. So it connects to the OpenNode API there using our the port we set and the URL details, and then we build a string with the amount, the description, which we wrote earlier, which was sweets, and then no routing hints because we want a nice small invoice. Then it makes it uses the HTTPS client to send our post request. Post requests and get requests they're a very specific format. You don't really notice it obviously when you do it through a web browser because it kind of takes care of all that stuff for you, but we're having to build this from raw sort of to make that post request. So we send a bunch of headers which it expects. So in order for us to actually connect, it wants our API key, which we send it. Which we just made before. We tell it what sort of application we're expecting. We're expecting JSON back, and then it sends the post request. So we're saying we want an invoice for 800 satoshis with a description sweets, and we don't want any hints. And that's basically what all that stuff does. It gets back some data, which it puts in a string called line, and then it kind of cleans that string up a little bit. The string is actually a JSON, so it's a JSON format. So we use our Arduino JSON library to sort of create a buffer which we can put our JSON data into, and then we can pass through that JSON data to kind of break it up and access the data. So that's basically what this stuff does here. So in our, in fact, if we go to the API documentation, we can show you in here. So generate a charge. So we generated a charge, and then this is, yeah, unpaid paid. Oh, it's checking to see whether the charge is being paid or not, isn't it? No, that is it. Oh, right, yeah, that is it, I think. Lightning invoice. Pay request. Oh yeah, this is it. So this is the data pretty much which we get back. So this is a kind of a filled JSON with our invoice request, with our and an ID and all that sort of stuff, and any other data we added. So as you can see there, we pull out the ID and we pull out the, where does it say data? Oh, data is just the sort of the top part of the JSON, and then we pull out the ID from there, and then so lightning invoice pay request, lightning invoice, there we are, see that? Don't know why it keeps happening. Lightning invoice and then pay request. Can you see that? Yeah, so that will get us our pay request, which it puts inside a string, and then it puts it inside our original string, which we set at the very beginning. So that's our post request to get the invoice data. So once we've gone and got that invoice data there, okay, we take, so now we've filled out with a nice juicy new invoice, and we send it to our QR maker function. Now our QR maker function, I think, is down here. Here we go. So here's our QR maker function, which ends there. So it's quite a big function. As I said, it's really fiddly to make a QR code in order to, display it on the fly, then display it on the ePaper itself. So let me just quickly whiz through what this does. There's a bunch of stuff we don't actually need here. We can just delete. We can delete that. We can delete all this. I should delete this off the GitHub, really. I'll do that, in fact, because it's just unnecessary and confusing. So we take our QR code, we take our invoice, we turn it into a QR code made of ones and zeros, as you can see here. There's multiple ones and zeros in order to kind of get the right size so it fits the ePaper. That was quite fiddly to work out. And then once it's done that, what does it do after that? Let's go have a little look. Here we go. Once it's done that, it then passes through those ones and zeros and then it tries to, here we are, here's our hex value thing. This is our dictionary where it parses through and it tries to match those ones and zeros with characters, so it can then actually build those hex values and then put those hex values inside a character array, which is then our bitmap, essentially. So that's what all this stuff does here. Yeah. Do I need that? Yeah, no, well, no, I don't need that, do I? That's okay. All right, okay. Right, so once it's done that, obviously, it then sends the data to the display. It draws the bitmap, which is locked up in this array called single hex, and it's 184 by 183 pixels. And it draws that onto the ePaper. And then we're going to start checking, aren't we? So we're going to use this check payment function, which is the next function here. So this is much the same as the one above, the fetch payment function, except this is a bit simpler because it's just a get request. So we're not actually posting any information. We're just saying has, yeah, here we are. So here's our URL string. There we are. That goes in the top there. Has the invoice we just generated, has it been paid? Yeah. So we're just going to ask that, and I think I've got like kind of a while counter under 30. So it's basically it's going to run this. I think it takes like maybe a second or two to run this. So it gives us kind of like 30 seconds or a minute to pay that invoice. And then if we don't pay it, then it just resets the whole module, the whole ESP32. So if it's unpaid, yeah, there we are. It waits a second, then it checks it, and then it adds one to the counter. So it keeps looping round. So then the counter's 1, then it adds again. This counter's 2, 3, 4. So yeah, so you have 30 seconds to kind of, well, it's probably about a minute by the time it's checked to see if it's been paid. Or 45 seconds or something else. So if when it checks the data status, so if when it does this check payment, it returns, so essentially it's hitting this, if it returns paid, here, then we're going to turn on the motor. So we're going to say on pin 27, which is then going to activate our transistor and allow the 3 volts to go to our motor, and it's going to run for 4 seconds, and then it's going to hit a low again, so it's going to turn off. Then we're going to wait half a second, and we're going to say counter equals 30. So that will break this while loop here. Yeah, that makes sense. And then once the loop's broken and once we're out of the while loop, it then clears that counter peripheral for the next time we run that. And then it runs another page on the ePaper. So it flashes the ePaper white, and then it says, oh, this is for the next invoice. So once the invoice has been paid, it then says, you know, only 400 Satoshis, press button for QR. So essentially it prints that onto the ePaper, and then it goes to sleep. So when someone comes along, they read on the ePaper, it says press button for the QR code. You press the button, and what that's actually doing is it's waking the ESP32 up from its sleep, and then that's running all of that script all over again and generating that QR code. Okay, so I think, yeah, wow, we've covered all of it. So that is all of the code there. This is kind of the moment of truth when we plug in our ESP32 and we upload our program and we see whether it's going to work. I doubt it's going to work for the first time. These things rarely do, but there we are. So I'm going to plug him in to my ESP32. This is where I find out I've got a faulty ESP32, Okay, hit boot. Well, it's uploading, which is miraculous. Connecting. Connected. Okay, so it connected to the Wi-Fi. Oh my goodness. It says loading on the, oh my goodness. I mean, I know that I shouldn't sound as surprised as I do. I really like, wow, Blue Wallet's really nice. Kind of loaded up a little bit quicker than Eclair. So I click on the little red button. It says loading on the ePaper, which you can't quite see because it's not in focus. How do we make that focus on there? There we are. Okay, and now I've got my QR code. Click on send, scan, use camera. I got a crappy camera on my phone as well, so well done Blue Wallet for... That's not as quick as the last time. There we are. 800 Satoshis. Focus, please. Well, you can kind of see the blurriness of 800 Satoshis there. Okay, I click on pay. It pays blazingly fast. Ah, it's typical, isn't it? So before, when I said about the wires in the motor, if you get them all the way around, then it's just going to kind of push the sweets back up into the machine. That's what it's doing, which is a little bit annoying. So there we are. So as I said before, the motor, be careful, I'm very excited, I don't want to like yank all these wires. The motor's kind of bi-directional. So if I change the two, if I swap the two wires coming out of the motor, then it will just change the direction in which the motor spins. So just as luck would have it, you may be lucky enough to get it right first time, but just as luck would have it, I had it the wrong way round, which meant that the motor was spinning the wrong way round, which meant this little thing was curling the wrong way round, which would push the sweets back up into the machine. That again is something when I made my first one of these that I already got stuck on for quite a while. I couldn't work out why the sweets weren't coming out. I've managed to screw everything back in, and I'm going to be cavalier, and I'm actually going to put the lid on with the expectation that my motor should now spin the right way around. And I'm going to fill this bad boy full of sweets. I found Smarties seem to work the best with the sweet machine. And he doesn't like Smarties as well. There we are. Cool. Right, so there's like an old QR on there. I suppose that probably should go away in a second if I wait for it to go away. Or I could just hit the reset button, couldn't I? So I hit the reset button because that just resets it, so it doesn't matter if there's a QR there. It says loading. While it's doing that, I suppose I could click send on there and then click scan. Yes, I want to use my camera, please. It's loading a QR code. This wallet is like a lot better in low light as well than the Eclair one seems to be. Click on pay, and then moment of truth. The motor's right around. It says paid. Yeah, baby, look at that. That's brilliant. Oh, I'm scamming people. Only 400 Satoshis, what a lie. I should need to change that so it says only say 800 Satoshis. I'm actually trying to scam them out of an extra 4, which we all know will be worth a lot of money in the future, those extra 400 Satoshis. So I click on the reset button. So when it says, you know, only 400 Satoshis, press the QR button to reset. It's using like, I think it's 0.04 milliamp hours of battery. Oh, so quick, look at that, brilliant. Click pay. I'm loving Blue Wallet. And out it spits. And that's why they call it Lightning Network, so very fast. Brilliant. And again, I know kind of Blue Wallet is a custodial, but it's like for small amounts, like, you know, your Lightning, currently, your Lightning wallet Should only have a small amount on just for paying for small amounts, so it's the security trade-off is kind of worth it. But in time, obviously, we will have full non-custodial Lightning wallets on our phones. So, well, there we are. That's fantastic. That works. Now, the next thing we could try, if I can do it without dropping sweets everywhere, is unplugging it, and then, because this is an IoT, so, you know, it doesn't need to be plugged into the computer, does it? I get one of my little LIPO batteries for my collection. I'm amazed that worked first time. It's brilliant. I was just totally expecting loads of bugs. So, if you can see that, this is like, this might be impossible to do in front of the camera. I'm just plugging in this battery into the focus. I'm plugging in this battery, this little LiPo battery, into the VIN, so the 5-volt in, and the ground here. But they're kind of bent outwards, so it's really fiddly and annoying. And I don't want switch to go everywhere. Not unless I paid for them anyway. Ah! Ah! Ha ha! So there we are. There we go. So I've plugged the LiPo battery in. So this is now fully unconnected. IoT. Click on the reset. Click on scan. Use camera. Yeah, I can't recommend Blue Wallet enough. It really is pretty cool actually. And fast, so fast. Okay. And then scan the QR code. Oh, that's more like it. Click on pay. It's paid. Give me some sweets. Fantastic. And then it resets to only 400 Satoshis. So now it's asleep, it's not using any power. That's a 500 milliamp hour battery. So now it's running at 0.04 milliamp hours. So it can be asleep for like months. And then when it's awake, I think it uses like 70 milliamps or something, because it's obviously got to run the motor and all this other stuff. So it uses quite a lot then, but yeah, the battery life should be pretty good, We'll see, we'll do some tests. So that totally worked, first time, fantastic. There's my little LiPo battery there. If I dare angle it, and there's a couple of sweets are gonna fall out there, but if we press the button, it should reset and give us another QR, ready for the next customer. Fantastic. So thanks for joining me on this very successful little project. Good luck making yours. Just follow the video, you should be fine. If there's a fly in here, follow the video, you should be fine. If you have any problems, then you know, drop a comment on the GitHub or hit me on Twitter, BTC Socialist. But yeah, enjoy your hacking and cheers.